Okay, what's up? Good morning. What's up, Yoli? Okay, so we're currently in the Tessellation pit, but I think we're gonna climb out of it today. Yesterday was a lot of geometry, function definitions and stuff like that, but today we're hopefully gonna be able to use these. Before I begin, though, I just want to quickly explain this new approach and how we take all of our constraints we have into account, and hopefully how it will solve it. So we're gonna jump over real quick here to this figure, which has followed us for quite a while. Okay. And I want to take this one, I think. There we go. And I want to bring it down to... I'm going to bring it down to here. So this is our mesh, our subquad we're working with. Yo, what's up, Sasanidas? What are you trying to make? What is this? Macro perspective, a creature collecting game much like Chow Garden in Sonic. Micro perspective, we're trying to get our tessellation to work so we can use it properly for our ground and snow and water and things like that. I would like this sphere here to be... Can we do alpha here? Or we can just disable fill. And let's change the line to... gray. Gray might not be the best. Let's go with green. There we go. And then I want to bring it down to about... something like that. That's a perfect. So Sunil, how long you think it will take until you're done with tessellation? We'll probably... I'm trying to be optimistic here, but I'm pretty sure we will be done this week. Pretty damn sure. There we go. We can add one last circle as well. Right about here, I reckon. Something like that, right? Okay, so from the camera position, we measure the the distance to the point we're rendering, and this distance, we split it up into chunks or deltas, and one delta length is the diagonal of one subquad. And then the idea is that if the idea is that we tessellate the subquads according to so we take the closest point for each subquad in the we take the closest point on each subquad to the camera, and we tessellate the subquad based on that. So in this case, I was hoping I would be able to... Let's do it like this then. We have a selection tool here, maybe not. We bring that one to the back, that one to the back, this one to the back. That can we select? Fucking hell, whatever. So the idea is that this one, this one, this one, and this one, and this one, they are all within the first sphere. So we tessellate them. This is a very bad visualization. Let's fill them instead, and we fill them with this one maybe. These are tessellated the maximum amount. These are tessellated Okay, let's try and do it without visualization. These 5 are tessellated the maximum amount. The ones that are inside, or that have one point inside the second sphere, is also tessellated the maximum amount, but we interpolate them. The one on this, in this sphere, so that's this one. They are tessellated the maximum amount, or x minus 1, 2 to the power of x minus 1, and they are fully interpolated. Fucking hell, does this make sense? So if we take this one, for instance, it will be tessellated the maximum amount, or 2 to the power of x. This but at this point it will be interpolated 0 times, so it will have a height as if it wasn't tessellated a maximum amount. So here we have no so it's the same here. Okay, I think we're gonna have to do this. So for each quad, we calculate how much it's tessellated. This one will be tessellated maximum amount. And then we're gonna do... yeah, and that will work. So it's a question of how we interpolate the heights. It's important, like here, okay, I think we're gonna start by, so we're gonna calculate a tessellation constant, and that constant is going to be 2 to the power of x. So 1, 2, 4, so on. And then we have, if we have a tessellation of 2, actually this one has a tessellation amount of 1, 2. We subdivide it twice. 1, 2. So then we know that 1 divided by this, those are the new points. So this one is old, this one is old, this one is old, this one is old. Yeah, let's start with that. So we're gonna use this new technique and we're gonna mark them as new or old. I want to do terrain tessellation test. Tessellation exponent. Yeah, we're gonna have to calculate this one in a different way. It's okay. Let's see what we have now. We have the closest point. So here, for each subquad, we want to calculate nearest point on quad with normal. Okay, we're just gonna start by doing we're gonna take one delta. So if the distance is, we calculate the closest point, then we calculate the distance to the camera, and then we divide that one with the delta, and then we take the full number. Very similar to what we have done before, although I wonder if yeah, we calculate that. I wonder if we want to do round. No, we want to do floor. Okay, so it's going to be very similar to previously. So calculate tessellation exponent, position vs camera position truncated. We're not going to use that one. We're not going to use step. What do we need to send in here? We're gonna send in nearest point on quad with normal. Let's take this one. Step. Just gonna remove this as well. View vector. We calculate the culling first, and then we start with this. And what we do here is tessellation amount power minus tessellation offset. Okay, so we do this. Float tessellation exponent is equal to calculate tessellation exponent, and what we send in here is this one. So we create a quad out of these 4 points making up this sub quad, or we define a quad with the help of them, and we calculate the nearest point to the world space camera, and yeah, that gives us a point. Reference point vs, and then we do float distance is equal to length between reference point in world space and camera, world space camera position. And then we have our delta. We calculate that one on the CPU and send it down. That's mesh subquad diagonal. Where do we have that one? Mesh subquad diagonal. So when we have calculated the distance, we do float offset, or tessellation offset. This one is equal to math. Oh, that's not what we do. Floor distance divided by mesh subquad diagonal. So we pretty much calculate how many between the camera position and the nearest point, how many diagonals fit there, and we do floor on it, and then we just here we return tessellation max tessellation amount pow minus tessellation offset. So in my mind, if we have the nearest point to the camera for this one, it's less than one diagonal, so we get 0 here. We get 0 for this one and this one and this one and this one as well. This one, however, is pretty much exactly this one is also less than one diagonal. That's true. But this one is one more than one away. It's probably one. Then I wonder. Yeah, this should work. So our tessellation exponent is calculate tessellation exponent, but actually we calculate it here. And then we set all the edges and the inside to be equal to this, 2 to the power of this one. Then we want to do the same for neighboring points. That's what sucks. But it should be okay because we want to figure out the seams. My question now is, do we really need to do it with the nearest point on quad? Or can we just set this one? This one gets its point here, this one gets its point here. Okay, we can't really do that. So what we want to do here is we want to replace this one with create a method for it. Basically, we want to do this for all the neighboring quads as well. Then again, I wonder, we can probably do it in a cleaner way eventually. Yes, we can. We can do it in the geometry shade. I don't think we need to send down seam. Do we? Or we can actually do it like this. Calculate tessellation exponent. I had an idea that if we do this one, we want to calculate the tessellation exponent on this one. Or eventually, we can actually do it like this. So when we fix in the geometry shader, when we calculate these edges here, we can just check should these edges be tessellated less, then it's quad tessellation. If so, we know, or should they be tessellated more? Is that? We do. Good morning, Harukanan. We can start by solving this the way we know works. But eventually we can hopefully clean it up a bit. So this one will be tessellated the maximum amount, this one won't. We need a way for these to know that they are not enough, pretty much. I mean, it's easier to do the other way around. Okay. We're gonna do it the expensive way for now. So float. Compare. Tessellation exponent. Yeah. So here we want to send in P1 plus offset P2 plus offset P3 plus offset P4 plus offset, and then our normal float 3 0 1 0. Finally our world space camera pulse. And then we do return if calculate tessellation exponent for P if this one is bigger than tessellation exponent. So our seams will just be equal to compare tessellation exponent. Batch 0, we're just gonna take all of these. And then we want the offset as well. Seam. So edge 0 is this one right here. But then we want to go downwards instead. So the offset should be mesh dimension, mesh resolution, mesh subquad diagonal. Mesh dimension minus mesh divided by, so mesh dimension, oops, subquad sides. We want to multiply this one with, and we want it to move downwards, so float 3 0 0 minus 1. And that's for the first one. So for seam 1, we want to go to the left. For seam 2, we want to go up. And for seam 3, we want to go to the right. Something like this, we can check if it works soon. Okay, I think we can check if it works now. Let's see if we have any compiler errors. There's a lot of calculations being done there, but it's only on the original vertices, which... length, yeah. This. Tessellation exponent 1 Oh yeah, we want to send in that one as well. We... I think it works. Seam still works, right? It's pretty good. I don't see any apparent wrongs, so we can see sub quads here. They have the same amount of vertices. We do it based on height from the camera as well. I'm a little bit... I wonder about this one though, if we only rotate the camera. But that doesn't really matter. And then we can bring this one up to 6. So this is the amount we would like to tessellate eventually. Looks a little bit too much. Maybe not. $250. Although I wonder. Definitely looks a bit too much if we go back to 3. Do we really need to... Worst case scenario we get... We never get... Yeah, worst case scenario should be a length of 3, neighboring subquads being tessellated the most amount. Sure, so we get 3 times 3. I think that's okay, but it looks good. We get 2 here. Is that necessary? Yeah, probably. This looks pretty good. I'm happy with the seams working as well. We never have neighbors. We're actually too liberal with, like, we are tessellating a bit too much as opposed to what we would need, I would guess, but maybe this is good. like that it works with height, even though we're probably not going to need that. This is a way better approach to it. Although I wonder, we always have a minimum of 1 subdivision here. Do we never go lower than 1? Would I like to allow for 0 subdivision? So the culprit for that is compare tessellation, calculate the tessellation exponent. We do tessellation amount power minus this one. And then we do tessellation, we do 2 to the power of round here. Yeah, so if this one is 0, we're still gonna get 1. Do I wanna allow... yeah, division by 0, we wanna avoid that, but... Tessellation... Actually, we probably want to do tessellation amount power, tessellation offset. Yeah, okay, so this one can be 0 at most. And it can be... yeah, it can be pretty damn big eventually. Tessellation amount power... So if we return a negative value here, fuck, that's a little bit of a... what happens with 2 to the power of a negative value? Chillhop. Here we go. So why? If it's less than 0, we get in. That's only if, okay, less than 0. If this one is greater than 0 and this one is less than 0, then we get 1 divided by. Okay, so we get 0 point something. I reckon 0 point something, we round it to 1 or 0. I want to do floor here. I want to see what happens if we do 0. Okay. If we do 1, then we get this. We can see here that we have a little bit of a... okay, we calculate these the wrong way. My question is... because we have a subquad here, if we don't tessellate at all, I would have hoped that this is probably okay. Probably, I say. Ooh, here we get a 4 times 4. Yeah, we're a bit too liberal with when we do a subdivision or not, but yeah, it will probably work. But we have edges here. That's something we don't want, and that's why we do floor. If we do round instead, okay, we still get it. So we identify edges where we shouldn't. Okay, that's a problem we have. Yes. Because I think we want to do max of 0 and this one. Yeah, there we go. And I know now why we get this last subdivision here. It's actually entirely on us, or entirely on me, because this last subdivision, we do it in the geometry shader. So the tessellation shader actually sends down no tessellation here, and then we add a few. So yeah, the subquads far away from the camera, they are the perfect example of although I wonder. So pretty much what's happening is this gets turned to this, but that doesn't explain the middle ones. That's true. Okay, let me just do... Let's disable the geometry shader real quick and see what kind of result we get. We get these subquads. And then our geometry shader splits it like this. But it also splits it like this. Right? It also splits it like this. Yeah, of course. Yeah, we get... Yeah, so it's a perfect example of this. From the tessellation shader, we get the white vertices and white edges, and then our geometry shader splits it like this. So our geometry shader does one extra subdivision and then one topology fix, basically. Okay, so I don't think I have any more questions here. Everything looks good. I think. So now it's the damn interpolation we're gonna have to get in place. And I think we can do it like this. We're gonna start by doing what we have done so many times before. We're gonna identify the new points. We are gonna identify new points. But I want to identify new points in a little bit of a different way we have done previously, I think. Or some time ago we actually identified it like this. So it's basically, we're gonna take the UV tessellation we get. Each subquad gets its own UV coordinates, or the X and Z or X and Y are flipped, but the good thing is that this UV goes between 0 and 1 for one subquad. And because we tessellate with 2 to the power of X, all of our UVs are going to be in steps. So we're going to have UVs that are 0.5, 0.25, 0.125, 0.0625, and so on and so on. And we can use this one to calculate if it's a new point or not. But we're gonna have to send something down. So in the hull shader patch constant function, we get a tessellation factor within inside edge and inside. The way we do tessellation, we know that all of these are equal, and they are also equal to both of these. So in our domain shader output, we send UV, UV tessellation, and seam. And I also want to send in I think I want to send float. Actually, we're gonna put it here. Float UV tessellation step. X chord 3. So down here we calculate, or we have seam, we have output P. That's our point. We can leave that one for now. We do UV tessellation is equal to UV tessellation, and what I want to do here is output dot UV tessellation step is equal to 1.0 divided by factors dot edge 0. So basically this one tells us what is the UV step length between the smallest, or between the vertices after our tessellation. And then we can do I wonder if we want to divide this one by 2 as well. Or maybe multiply it by 2. So this one, after tessellation, we will have 0.5. The value of this one will be 0.5, and that's the step from this one to this one, or yeah, pretty much the step from any vertex to another. don't care about these. The only... Yeah, we can do it like this. Let's print this one and see what we have. Basically want to do... I want to figure out how we should handle these. Could we do? We have some original points here, then we create new points. We start by doing this. Float P, float test, export 5. For all the new ones we do output.test is equal to UV tessellation dot x modulus. We can just take P1 dot UV tessellation step not equal to 0 or UV tessellation dot y. There, P1 dot UV tessellation step. Something like that, and then in our fragment shader we just do return input.test. Or actually, yeah, we want to do it like this. We get the same pattern we have had so many times before. That's good. With the only problem that these points are, yeah, with the only problem that the seams doesn't work, but we can probably fix that. New point, new point, new point, new point, new point. this one actually gets marked as a new point, but this one doesn't. Hmm. Mm-hmm. So is that a simple problem of this one doesn't get marked as new either. We might want to do this comparison with an error margin, actually. But old. Tessellation. That explains it, I think. Yeah. That only explains the fact that we're not setting it here. What's up, John Olson? Have you tried the brute force plugin? I don't know what brute force plugin is. So no. That's beautiful. Could this have been the error? Turn input dot test. It's a snow and ice shader. No, I haven't. I'm gonna look into it after the stream if I get the time. Looks interesting. Okay, so what do we have now? Same issue. Why in the world does this add? We interpolate these ourselves, so we might want to do comparison with. Let's see, do we have that? HLSL compare float. Pretty sure we should have this one somewhere. Average truncate. HLSL epsilon. Okay, we don't want to do this. Okay, so let's do UV tessellation, this one. We just need to check if it is... UV tessellation. 25 gives us 0.25. Now we should be able to just do if it's greater than something, right? That's not entirely true. It could be zero point. So if we have 0.49 modulo 0.50, we get 0.49. We want to take minus. I'm thinking, do we want to do this? Minus. That's not entirely true. Now we can probably just check if it's no. So we want to check for if we get 0.001 or 0.49999. It's also extremely weird. I don't think... Might still be. Fucking hell, are you serious? Oh. What did I change here? Huh. Okay, this is beautiful, except for the part that... I have no idea what changed for this one to work. Okay, but the only problem now are these points right here, but we can fix that pretty easily, I think. So if we check this point right here, it shouldn't be marked as new anymore. And we can easily fix that by, in the domain shader, if seam is true, if the one, so we want to calculate this one first, we can bring this one down to here. Let's bring this one down as well. I don't think we need it. Oh. So if it's a seam, the tessellation is one step more, right? If we take a look at this one, we can check here that, so for this edge, we're actually tessellating a bit more. So we want this one as old, this one as new, this one as old, this one as new, this one as old. So we just have to tell pretty much if... Can we do it here? I wonder. We don't want to do it on this side, we just want to do it here. Okay, so we can't do it here, but we can do this. So when we calculate S01, 12, and 20, so it's these two, S01 and S20. Pretty much down here. So when we calculate S20 or S01, we can do it when we are in seam. So when we do create point from and we set, before we do test, UV tessellation, we want to do UV tessellation, and we do output.UV tessellation step is equal to, if both of these are seams, So we can pretty much do p1.seam times p2.seam if both of these are true, we get 1 here. So the problem is here, if both of these are true, we want to subdivide UV tessellation step by 0.5. Otherwise we don't. So we can do p1.uv tessellation step divided by +1. So if one of these are 0, we get 0 inside here, so we just get 1. So this is our tessellation step. If both of these are 1, we get 1 here, +1 we get 2, so divided by 2. And then we use this UV tessellation step down here instead of P1. Yeah, we need one of these here as well. Okay, it wasn't as easy as that. What did I fuck up? Didn't fuck up too much. Why doesn't this work? I thought it was pretty smart. P1 tessellation step. Could we get a floating point error this time around? Yes, we get 1, 1, 1, 1. Has to be a... But we should be able to do if output seam. I don't know if that helps. No. Okay, so if we can take floating point, I just want to make sure it's not a floating point error here. That's behind this. I just want to try if we do output test is equal to UV tessellation step output. Yeah, this one is definitely lower. These ones. It should be 0.5 here, shouldn't it? So we definitely get a change. Is it? step, UV test. So we get a bit darker here for some reason. So here it's 1, here it's 0.5. Here it's 0.5, 0.5. And here it's 0.25. I know why. Because we create... Yeah, we create this one and we create this one. And then we create these from... Or actually, no, not these, but these. So we do it 2 times, that's not good. It's pretty much like this. We create this point, it's between 2 seams, so we subdivide it. Then we create this point and we subdivide it again. But it's a bit weird that... Yeah, and this one doesn't get it because... We do P1 tessellation step here, while this one does this one, yeah. So we want to do... We can solve it by this, P1 tessellation step, P2 UV tessellation step. Think... Yeah, now we get the same color here, but does it look a little bit darker than this one, doesn't it? I think we want to get that, do we? Take max? No, I take min. We want max, I reckon. There we go. That's... So that's that problem. So here we get UV step of 1. This one 0. For this one 0.5, 0.5, 0.5. So the UV tessellation step is correct, but we get a little bit of an... No, 0.25, 0.5. Five 0.5, yes. Good morning, PG King. Yeah, I'm gonna chunk this up into a floating point rounding error. Pretty sure it's that. Let's see if we can fix that. And let me guess, still working on tessellation. Yes, unfortunately, yes. But this is gonna be the solution that solves everything. Okay, the hard part is that I want to check a floating point. I want to check a floating point error that is... We could either get 0.01 here, for instance, or 0.4999 or something like that. We need to check both those errors. I don't know. Actually, we can do it like this. We know that UV tessellation step is roughly 0.5. Oh, one sec. Okay, so let's take a look at this one. This one has a UV step of 1. But for the edges here, so this point, and this point, we subdivide it by 2, which gives us 0.5. If we do UV tessellation modulus 0.5, this one should be original. This one should be 0, but it's not. Let's see here. Oh, we're gonna have to do 2 checks here. We can probably do... I wonder if we need to do something like this. if it's less than 0.01, then we have two ores. If am I checking the correct thing here? If is equal to 0.0 or is equal to 0.0. Test, we want this one to return 1 if it's a new point. So shouldn't that be not equal to? Have I... Old point, old point, old point, old point, old point. And this seems to be it, doesn't it? White are new points, black are old points. New. Old point, old point, old point. This one I'm a little bit worried about. Yeah, we want to add an extra check. Middle point should be old point as well, right? Here, this one is a new point. Here it's old, that's good. Why is this one getting marked as a old point? That's a little bit weird. The center points, we want those to be old as well, right? The new point, old. This one right here. So we want it to look like this, don't we? If we mark the center points, yeah, the center points are old as well, aren't they? Yes. Zero 0.5. So we want to check for center points are never new, and the center point is this one. Actually, yeah, the center points we're talking about. Yeah, S112. So it is this one. They are never new, right? No. So. We can check these 4 points. They exist here, and here they are marked as new. But the center point. This one exists in this iteration. Here we have it again, it exists again. So we actually get the correct result here, but not here. So why is this one marked as an old point for this one, but not for this one, I wonder? So this behaves correctly. Center points are weird. So basically, worried about this one here as well. We could just send in, much like we have done here, but I want to solve this mathematically. Same goes for this one. Yeah, it's properly marked. So here we have 0.25. Check. Okay, so 0.5, this one is at, or we actually have one here. This one is at 0.25. I mean, could we do, if we take the UVs, sorry, and we add them together, and then we do the modulus on that. That would give us 0, 0, 0, 1, 0.5, 0, 0.5, 0.5, that's 1. But would that fuck our edges? Maybe it would. Okay, so if we go with the, if we just send in this here and we do some new point, this one is not marked, so it's false. And then we do, so if new point is 1 or actually 0, new point times whatever we'll return here. Now we have this, which is perfect, I think. I wonder if this is useful to us, however, when we want to start interpolating. Actually, maybe it is. Now we have a binary value that is either 0 or 1. If it's a new point or not. And I wonder... all the new points we want to interpolate as well. We want to interpolate them by... like, it's extremely important that we interpolate them Yeah, now we just want to figure out the age of them pretty much. But it's very important that the new ones here has the same age. But we should be able to calculate that by doing... distance from the point we're working on to the camera. And how close it is to... So whatever vertex is white here, we want to interpolate the value, and we want to do it I'm a little bit worried here. This one is white here, and that's good. It's also white here. Then again, yes, this one has... Could we just do... Okay, the problem is basically that for this one right here, all of the white ones should have... Not all of the white ones. Yes, right about here, all of the white ones should have an interpolation that is close to 1, interpolation value close to 1, apart from these. They should be calculated in another way. Yeah, and we should be able to do it by... So we need to do it related to whatever UV tessellation step is. Think. So basically we want to calculate okay. So for all the white ones here, we're gonna calculate a interpolation value between 0 and 1. It's related to this one here, for instance. It should be right about here. It should have an interpolation value of 1, and then it's a new point here, so it still has an interpolation value of 1. These new ones should have an interpolation value of 0, but it's the seam points that are the complicated ones, because this one should have an interpolation of 1, but this one shouldn't. It should have an interpolation value based on its UV tessellation. This one has a UV tessellation of 0.5. Or this full square has a... That's not a full square. Zoom out a bit. Yeah, so this one right here has a UV tessellation step of 0.5. This one is 0.25. 0.5. Hmm. 0.5. Or actually no. This full quad have a UV tessellation step of 1. This has a UV that is 0.5 in one of the axes. 0.25. Yeah, it should be how close the point is to its I'm wondering if we can just, for each point, calculate the tessellation amount and then divide it by whatever tessellation have. What the hell is that? Fuck, so many things I'm gonna do after this. It's gonna seem so easy compared to this. Like, we want to calculate a relative value, but we want this point for this quad to have the same relative value as this point for this quad. And we can do that by the UV tessellation, whatever it was called. UV tessellation step. In some way, I think. So I wonder if, like, the error we get here, but we have two errors, and we have one have to be the primary one. I wonder if the biggest one should be the primary one. Or yeah, I wonder if we want, for each point we want to calculate its real tessellation exponent. Think so. if we calculate for each point, we pretty much calculate this, but we don't floor this one. I want to see what we get. So if we were to do calculate distance, but we do it by position interpolated vs minus world's camera space. We do distance divided by mesh sub quad diagonal tessellation offset. We do this. And then we do T is equal to, do we have T here already? Maybe we can just do K is equal to 1.0 divided by tessellation exponent. And then we take this one. Let's do it later on. Test, here we multiply whatever we have here with A divided by output dot UV tessellation step. What kind of visual render do we get from this? It's honestly... Not really what I anticipated, but it's interesting. we're getting values way greater than 1 points where we don't want it. Basically don't get... we get fading here, that is true. Okay, let's... I don't think this is too far off what we actually want to do. But for instance, if we get tessellation exponent, let's say that we have four, we get 0.25. That's because we floor it, and it's gonna become small. It's gonna become bigger eventually, so we might get between 4 and 8. So we might get 6. One sec, did I forget to do one very important thing here? Float tessellation is equal to pow to tessellation exponent. And then we do k. So calculate the tessellation exponent for this one. The offset might be, so if we have 4 up there, we might get, let's say that we get 5 here. Then we do 2 to the power of, or 2 to the power of 5, which is equal to 32. Or let's do a simple tessellation exponent. It can go 2 to 4. So let's say that we have 2. 2 to the power of 2 is 4. And then we have 2 to the power of 3, which is 8. So between 4 and 8, we calculate a better value here. So we might get 2 to the power of... We're never going to get bigger though, because it's always the closest point. So we might get 2 to the power of 1.7. With this, let's have this, then we do 1 divided by this one. 0.30. And we have 0.25. So this one is always going to be smaller. So what if we do... What if we do output.test is equal to... This one is always going to be smaller, right? So... Fuck, is it always going to be smaller? K minus output.tessellation step. UV tessellation step. We get by this one. We do get fade here, but we don't get fade here. Or we might actually... Yeah, we actually do get fade, but we also want to do divided by... No. I need to do some calculations here. So let's say that the full quad is tessellated 2 to the power of 2. This is... The tessellation offset down here is always going to be smaller. This one is always smaller. This one becomes bigger, doesn't it? Let's draw some stuff. Let's see if I can figure it out. Some nice figures. Okay, so if we have this subquad, we have our camera radius is something like this, and then we take this point. When we tessellate the full quad, we take the closest point to the camera, which is pretty much like here. So let's say that tessellation offset, this one grows the further away we are. Yes. Right distance divided by mesh subquad diagonal, yes. This one grows the further away we are. This one becomes smaller. But anyway, so for this point, let's say that we get 2 to the power of 2. We floor this one. And when we're further away, we get, so for this point, we get 2 to the power of 1.7 maybe. So the tessellation for the full quad is 4. The tessellation it should have is 2 to the power of 1.7. 3.249. Then we do 1 divided by this one, so we get 1 divided by 4, 0.25. 1 divided by 3.249, we get 0.37. This one is bigger. This one is gonna grow. Then I wonder if we want to take this one, A, B. I wonder if we want to take A minus B, which gives us 0.057. And then we want to take how close this one is to 0, right? But it's not relative, is it? So I wonder if a better option would be to take 0.25 divided by 0.37, 0.81. The closer this one is to this one, the more this one will grow right now. Yet the smaller this one will get. So yeah, and this is pretty much how close we are to it. So do we want to take B divided by A? Isn't that something? Didn't we do something like that? Now we did K minus, so let's do K. Output UV tessellation step divided by K. We don't get any fading whatsoever. Why don't we? Now we do get it. Here, I would like some fading in levels pretty much. This fading looks pretty good as well. We can compare it to... And this fading right here looks beautiful. So here we enter a new... We don't get any jump there. What am I missing here? UV tessellation step divided by a new step. Dude, this one divided by K, it should be related to whatever tessellation we have. Damn close, I think. 2.25. But we don't handle... Why don't we get any fading here? If we do K, let's just return K here then. Get greater than 1 over here. Doesn't make any sense. Position interpolated vs and so distance divided by mesh sub quad diagonal. Then we do max here. How? The closer the point is, tessellation. Now we get some nice fading, don't we? Okay. It's not perfect. For how long did I have tessellation exponent here? So if we do the calculation we did previously, but we do tessellation here. Mm-hmm. You see here that these are whiter or brighter, so the closest ones are brighter. Is this I would love to have it doesn't seem to be going between 0 and 1. That's what I would like to have. So pretty much, so here they are very bright, even bigger than 1, right? That's not good. Why is that? UV tessellation step divided by K. K should always be bigger. No, that's not true. Could do float interpolation is equal to B divided by A. If we do inverse lerp, What the fuck, shouldn't it be as easy as... Am I overcomplicating stuff right now? No. Maybe I am. The thing is that a point we take here should never be closer to the camera than the closest point on the quad to the camera. So I wonder if we could use that fact. So, well, maybe I've been overcomplicating this as usual. I guess this one would be the closest one here. Well, if Okay, let's not think about the edge points, the seam points. Let's just care about points on the actual quad. Basically, like, we want to calculate so we have 2 layers of, within this one we tessellate 2 to the power of x. Within this one we do 2 to the power of x minus 1. Wouldn't we like to just calculate like the point's position here? How far between these two is it? We can do that by destination. We don't need to, we can just calculate distance, I reckon. And then we do, then we do this. Let's call it something else. Progress is distance divided by, that's not really it. Modulus mesh subquad diagonal, right? So 1, 2, 3, so we get 1.5, 2.5 ish, 0.5. How close is this point to getting interpolated into the next step? To this one. The problem being that this one has already, since the closest point on this quad is within this one, we have already tessellated once more. Distance we get then is to when we tessellate it the next time, isn't it? Yeah. Just want to see what this renders as. Progress, progress, progress. Yo, what's up, Spires? Thank you for the raid, appreciate it. You too, you too. But this result is extremely weird, isn't it? Never mind, it's not. Because our distance is full numbers, yes, so we might get 1.5 here or whatnot. So do we want to do... Yeah. If we want to get it as percentage, shouldn't we do... this could probably... we have some errors with this one, I think. But the thing is... Okay, distance we do... So that's how many times... No. Have I completely lost it if I want to do... Does that make sense? I think this makes perfect sense. I think this might be... How does it look between subquads? I'm having a hard time trying to decipher if this works or not, or values we're seeing here. And we use this 1 minus all of this. no. Why, oh why, oh why? Yeah, it's extremely close, but not quite there just yet. Looks pretty cool though. The problem being I actually think the previous solution was a little bit closer to what we actually wanted. I'm talking about, was it this one? I wonder if we have the closest point, if we send this one onwards, then we have this point, we have this distance, we can calculate this distance, we can also calculate this distance. I wonder if this, or how much longer this one is compared to this one, can help us. No, we're so fucking close with this one, because we need it to be relative to how many times it's subdivided. It's extremely close. That would handle our extra points as well. It looks cool. I don't know if that makes it better or if it makes it Like it's almost like it's taunting me, you know? So we calculate the actual tessellation for this point. We calculate the actual step for this point. So close. But the edge point might have... But... okay, one sec. Okay. Progress. Progress do, that's our calculation of how far we are towards. Is it the next point or the previous point? The next point. So how close we are to the next point. These points right here are extremely close. If we don't take... If we don't take the edge points into account, so these... Closest point stuff is fucking insane. Come on. Fuck, I'm gonna have to do some real detailed drawing here to get this under control, to fully understand it. How can we do that? So each point basically keeps track of how many, like, in what subdivision order it is. And we want to animate it based on that, which makes me wonder. Each point keeps track of in what subdivision order it is, and we just want to animate them based on that. It shouldn't be that hard. Except for pretty much, if we have the camera and we draw a circle around it, within this circle, every vertex that has a subdivision of X should interpolate. Within this one, every vertex that has a subdivision of Y should interpolate, and it should interpolate based on the distance here. But when we get the popping, that sucks. Yeah, but I think it's something like that. Let me draw it a little bit better. So within this area, every vertex that has a subdivision value of 0.5 should animate, so we will animate them here. This full quad will have a lot of them, but we don't animate them here. Here we only animate one higher. If we render this data again, not this one. Or actually, I forgot to do, let's remove progress. Oh, nice. So all of the white vertices we see here, they are the vertices that are up for interpolation. So all the white vertices here they have two values. They have one interpolated value and one final value. The closer we are to the camera, the more towards its final value it should be. And it's highly close to the camera. It's extremely tied to... Actually, we can do it like that. Oh, we can do it like this. I think we might have the solution. So first of all, we want to calculate a interpolation value. Do I really? Let's see. Yeah, we can solve it except for the edge. It's pretty straightforward. So first of all, we want to calculate the interpolation value for the full quad. i.e. the closest point in this quad that decides the tessellation. How close is that one to flip over? Because if it's extremely close, then we want to interpolate all of them. And it should be 100%. That's all points. All of them. All the white ones. In this case, except for this one and this one. That's the only thing we need to keep track of. Okay, so we calculate a progress value, we can call it. And for every point here that is marked as white, or for every point here that has a UV tessellation step that is similar to the full quad. So for every output point, so one output point UV tessellation step is equal to this one, equal to this one. Because see here, for some points we change this. But so like for every point that doesn't get changed, like this, so we can base it on this, I guess. They are going to interpolate based on, or actually this interpolation value right here, it's our lower bound. Like at this point, all of the points needs to have an interpolation value that is, or a progress value that is pretty much 1, because we're gonna flip. Except for these then. Then we're gonna have an upper bound as well. So I wonder if we want to do... calculate an upper bound and a lower bound, and then we interpolate them after that. Should work. It depends on how gradual interpolation we want. I want... Okay, but the first thing is definitely to calculate this upper bound. If we have this upper bound, we can probably do some pretty interesting stuff. Like, I'm thinking about a lower bound all the time as well. I just wonder what that would be. So the closest point to the camera, it calculates like how close are we to flip. And at this point, all of these needs to be fully interpolated except for these two. They are based on the lower bound. And that is just the next iteration, isn't it? So if we have an upper bound and a lower bound and interpolate between them... that should work. But that is basically just a step to the next, I would say. Keep this one as white. So calculate upper bound. And then what the fuck? Calculate tessellation exponent. We want to calculate the progress here. We have reference point. Reference point. Makes me want to change this one a bit.
The easiest way to get into the meditative state is to begin by listening.
Seam E. We have done something similar to this, very similar to this previously. Progress, text chord 6. Just float, progress, text chord 6. Basically, it's just about... Progress is... this divided by this. That's pretty much our progress. So I'm gonna do some... Let's take this one. Writing a note to myself tomorrow when I gotta unpack all of this shit again. But okay, so basically we want to do temp, nearest point on quad with normal, float 3p, and then we do distance, and we do output dot progress is equal to this. Is equal to this divided by this. But we remove the floor here, but not this one. Okay, something like that. Then we have progress here. In the domain shader, we just need to do output.progress is equal to factors.progress. And then when we create point from P1 and P2 has the same progress, so we can just do P1, and I want to do P1.progress multiplied by this new point stuff. Reference point VS E. Okay, not really what I wanted. How could that possibly result in this? Distance divided by yes, and then we floor. So 5 divided by 2. Yeah. It's not division here we want to do. We want to do minus. This one is always bigger, as we do floor. And then we want to divide this one by mesh sub quad diagonal. I don't know what the fuck is going on here though, but I would do... Okay, and then I want to... We have the opposite here. Before we do anything... Ooh. Before we multiply with P1 progress here, let's see, new point. Okay, then we have the new points. And for the new points progress, the closer it is... Let's see here, what do I want to render? So for instance, for this one right here, we have the new points marked as when we get closer, I want these to fade to black, I reckon. So this is 1 minus progress. Did I not get a correct relation? Yes, I did. Okay. Times test. Makes me wonder what the hell this one is. Isn't this the correct calculation? So distance, how many times on... How many mesh subquad diagonal do we cover by distance minus the Lord? So if we have 5.9, then we have 5 there, it should be 5.9 minus 5. 0.9. Wasn't the division correct? No, not really. But we don't need to divide by this one, do we? Okay, so if, let's say that this is 2 and distance is 5 right now, then we get 5 divided by 2, 2.5. And then we get 2 here, so 2.5 minus 2, that's 0.5. That is the progress. Do we have a tiny bit of fading? I don't see it. No, we don't. Or do we? Yeah, we do. Look at this. But... the PG King, the golden is in sight. Yeah, I can feel it as well. So... I want to do... We want 1 minus P1 progress. So... Okay, this looks pretty good. But I wonder... So for white points, it's like, do I want it the other way around? I think this is the closest we've ever been to this last. Okay, so white ones are new. And then when we move... Why don't I get the nice fading here? So the white points here, they should turn darker at this point, and then we should get new whites. Why don't they? It feels like you're just fine-tuning it at this point, which is very encouraging. Yeah. I agree. Slowly but surely, all of the pieces are working together. 1 minus P1 progress times new point times this one. Look at this. If we do this. So this is a binary value. All vertices that are marked white here are new points. What I want to do is So when we get closer to this one right here, the white points should move more towards black, right? That's why we want 1 minus here, I think. So if progress is low, yeah. That's not at all what I'm seeing. Why aren't we getting... it's hella weird. But yeah, unfortunately it sucks when so close to the final result, but I have to run. I think we will finally close this book tomorrow. I'm pretty damn sure. And I really hope so. But yeah, I will continue tomorrow. Yeah, hype indeed. I'm probably the happiest one. I'm so tired of this shit. But it's weird. Like it's fun at the same time as it's incredibly annoying and hard. But yeah, we're gonna close off. After we've closed this off, we're gonna use this solution in our snow. We're gonna close the snow, and then when the snow is done, we're gonna do some gameplay implementation. I like day and night cycle, I don't know, simple stuff. I need to relax a bit. But yeah, we'll close this off. We'll finish it tomorrow. Thank you so much for watching. Appreciate it. And yeah, have a great rest of the day. Peace.